Okay, so here is problem 3 of homework 2 in ES110 statics. We have the UHart graduation tent is tied down to the linkage shown. Cable B has a tension of 950 newtons, which is theta B 35 degrees from vertical. Determine the tension FA and orientation theta A of cable A that produces a resultant of 1500 newtons up, completely vertical. Okay, so we've turned the problem around just a little bit, and we'll start out by, this is page 3 of the homework, and I am Dr. Deal. And this is the spring of 2021, and this is ES110, and we are on homework 2. So this is problem 3, and in our setup right here, I'll try to draw it a little bit, make it look kind of close to the original thing here. All this other stuff doesn't matter like all that much. Right here, okay, and so up there, and then we have so we have like a rope that's coming right this direction, and we have a force that's coming in that direction, that's FB, and then we have another force coming up in that direction, and we don't know this angle right here. Let's see, we'll put the angle right in there. That's going to be the X and Y. This is FA. And right in there is going to be theta A. And right in here is theta B. I guess they labeled this as A and this is B. Whatever. All right. So for the given, we have FB is equal to 900 newtons. Theta B is equal to 35 degrees, right? So I'm going to draw them as vectors because I like to keep my vectors only from the horizontal. I'm just going to write down what they gave us. The resultant is 1,500 newtons right here. So I have magnitude and direction, so that is a vector right here. And we want to find, let's just write it out. Let's find out, we want F A, right? Pretty much. Okay, so it's a little different from what we had done previously, but we can write out the things that we know, right? So we can go FB is equal to, let's see, it's going to be negative 900, because it's this way right here, times the sine of 35 degrees I, plus upwards 900 cosine of 35 degrees right there, right? So I will write this out down below, and 900, let's make it negative here, 35 sine times, so we get a negative 516.2 I, and then 900, enter 35 cosine times, we have 737.2 J, and these are newtons. We're given that R is equal to 1,500 newtons. Whoops, let me go this way right here. Wait. 0 I plus 1500 J newtons. So we will find that R is going to be equal to FB plus FA. Why didn't I go FA first? I don't know. I could have gone alphabetical order. It would have been nice, right? So write that out, right? So fill in these things right here. We could go that 0I plus 1500 J is equal to, I'll start with FB, negative 516.2 I plus 737.2 J plus FAX I plus FAY J. Now, what you do here is we solve for the i's. In the I direction, we have 0 is equal to negative 516.2 plus FAX. Therefore, FAX is equal to 516.2 newtons. And it's positive, right? That jumps over to the other side. Then we could go J is going to be 1500 and set it equal to 737.2 and then plus FAY. So FAY is going to be, and that one's still in the stack, so I'm just going to take those in there and I'm going to subtract them. I know that that just came out negative because I did the other way. So 762.8. Does that look familiar? No. Okay. So I thought there was like an interesting, and it's also positive right there, right? So the answer here is FA is equal to 516.2 I plus 762.8 J. These are newtons. We want FA magnitude square root of 516.2 squared plus 762.8 squared, and that ends up equaling, oh, and by the way, these are both in the stack still, so I can do that little cheating thing where I square that and I flip them and then I square that and I add them and I hit square root and I get 921.0 newtons. I want to find the angle that these are formed. Take the inverse tangent, rise over run, 762.8. Run is 516.2 and 62.8, 516.2, yep, inverse tan, I get it's going to be 55.91 degrees. So I could express FA as 921, I think, newtons, yep. And it looks like it's going to go up and to the right, which is what we had originally drawn up in here. So we go up into this quadrant, make a little thing, 55.91 degrees. Nice and neat and complete. So there it is, your homework problem number 3. And I am done for tonight. Yay! Gonna go home and see the wife.